Here we go with section 14.4, talking about the normal distribution. Let's just define what a normal distribution is first. Normal distribution is a frequency distribution that often occurs when there's a large number of values in a set of data. So we have lots of pieces of data in this set, and the graph of this distribution is symmetric, and it becomes like a bell-shaped curve. And many of you probably have heard that before. And sometimes it's referred to as the normal curve. So we get this nice bell-shaped symmetric curve, a little more symmetric than what I drew it. The shape of the curve indicates the frequencies in a normal distribution. And you'll notice that they're kind of concentrated around the middle area. This area here I have more. Notice the height of our curve is higher in the middle and then at the extreme ends. So here's an example of a distribution of many scores. This would be an IQ scale. And over using a lot of data pieces, they've constructed. So what we're seeing here is the IQ scale. 100 is set as the mean of the scale. And the mean is always in the middle of our normal curve. And then we start going out very precise sections at a time, and this is where the standard deviation comes into play. So you'll see here we've got 100, an IQ of 100 is average, and we've gone up to 145, but there exists IQs that are definitely greater than that. And then this one here shows 55, and there are definitely IQs that are lower than that. So what's this curve all about? We can talk about the area under the curve, you know, this area, this region that sits under here. That would represent 100% of our data. Under this curve, we can start slicing it up. And you'll see on the chart here, it talks about X bar, which we know is the arithmetic mean. So we got the mean of our data centering in our normal curve. And then I add 1 sigma. And remember, sigma stands for a standard deviation. So all we're doing is adding 1 standard deviation that has been calculated for the data that we're working with. And then we go out 2 standard deviations and 3 standard deviations. This designation here talks about subtracting 1 standard deviation, subtracting 2 from the mean, and then subtracting 3 standard deviations from the mean. Over a lot of repetition, it has been known that 68.3% of the data lie 1 standard deviation above the mean and 1 standard deviation below the mean. 95.5% of the data lands 2 standard deviations above and 2 standard deviations below. So that would include this region all through here, 2 standard deviations. And then finally, 3 standard deviations. Boy, we're getting almost all of the data 3 standard deviations above or 3 standard deviations below. So going from this area to this area and talking about this whole region under the curve here would be 99.7% of the data. Dividing that data up, this 34.15% added together, this creates 68.3% of the data that you just saw on that previous screen. This format here just lays it out a little differently. If I went 2 standard deviations above or below the mean, I would be at 97.5% of the data. Oh, 95.5. I think that's what I said. And then if I added all of these values together, 3 standard deviations above or below the mean, that's that 99.7% of the data that we were just looking at on that other chart. Okay? So this question here says, suppose that 300 values in a data set have a normal distribution. How many values are within 1 standard deviation of the mean? So this would be plus 1 sigma above and 1 sigma below the mean. Remember, our mean is X bar in the middle here. That tells me that 68.3% of the data lies within 1 standard deviation of the mean. So I'm going to take my 68.3% and multiply it by the 300 pieces of data. And if you do that calculation, you'll come out with 204.9 pieces of data. So almost 205 pieces of data would lie 1 standard deviation above or below the mean. The mean of a set of normally distributed data is 25 with a standard deviation of 2. So just giving us some facts here. The mean of a normal set is 25. So we know our mean is 25. The standard deviation is 2. So I'm just going to jot that down over here. The mean was 25 and they told me sigma, or standard deviation, is 2. I'd like you to sketch the normal curve for that. Well, we know our mean. The mean is 25. I'm going to go 1 standard deviation above that. And remember, standard deviation here was calculated to have a value of 2. So if I add 1 standard deviation, I'm going to be at 27. If I subtract 2, I'm going to be at 23. Here I added 2, and then on the other side I subtracted 2. And I'm going to continue to go above the mean. If I went 2 standard deviations above, 2 times the standard deviation value of 2 gives me 4. 4 plus 25 is 29. Here, I would go negative 2 times 2, and I would be subtracting 4 from 25, giving me a value of 21. What you see is a pattern. Everything increases by 2 each time. So I can guess 3 standard deviations above is going to be 31, and this one down here is going to be 19. Because we were counting by 2s, everything, a bandwidth represents 1 standard deviation. Fairly easy. If I have a set of 400 values that has a normal distribution with a mean of 82 and a standard deviation of 4, I'd like you to answer the following questions. What percent of the data is in the interval from 78 to 82? Well, these may or may not be very nice values. Let's sketch the graph to see if they turn out to be decent values. So I'm going to sketch the graph. Reading from this, I had a mean of 82. Right here it said that. And a standard deviation of 4. So sigma was equal to 4. Just like we did on the previous example, I'm going to start with 82 as my mean. And I'm going to increase by 4 because each standard deviation is upping it by 4. So when I'm at 3 standard deviations, 3 times 4 is 12. I should be 12 above the mean. 82 plus 12 should equal that 94. Here I'm going to subtract off 4, so I get 78, 74, and 70. Now let's go back to the question. What percent of the data lies from 78% to 82? Or not percent, but 78 to 82. Well, they're talking about this band right in here, right? From 78 to 82. If I look at the piece I gave you earlier, we're really just 1 standard deviation below the mean. So I'm looking at 34.15% of the data lies in that region. The next question, what percent of the data is in the interval from 82 up to 94? I'm going to clean this off. From 82 to 94, we're talking about this region here, which is a +3 standard deviation above the mean. So this chart is really of some use. It's very helpful. I would really want to add those percentages together. So I'm going to be picking up 34.15% added with 13.5%. That represents the 2 standard deviations above the mean, and 2.15% of the data, which is the 3 standard deviations above the mean. Add all those up, and that's going to represent the percent that sits in that region. So grab a calculator and do that quickly. I thought this was just kind of interesting data here. It talks about women's height and men's height, and I've pulled this information from Stanford University in a study that was done in 1996. The mean women's height for people aged 18 to 24 was 65.5 inches. That would be similar to 5 feet 5 inches. It had a standard deviation of 2.5 inches. So what does that mean on our normal curve? Well, 5 foot 5 inches is the mean, and then I go up by 2.5 inches, and we're looking at 68 inches, or 5 feet 8 inches, or as low as 63 inches, so 5 foot 3 inches, and 68% of the data, or of the population, fall in that range. And I would guess in my classrooms, that would probably be fairly true, that most girls lie in the range of 5 foot 3 inches to 5 foot 8 inches. Men's height, the mean is 69 inches, so that relates to a 5 foot 9 inch person. Their standard deviation is a little higher, 2.8 inches. So if I start out with 69 inches and add 2.8 inches, we get 71.8, so almost 6 feet, and then 66.2 inches, and 65% of the data would lie in there. Just some interesting stuff. I would like you to name the interval about which the mean in which about 95.5% of the data are located. 95.5% of the data. Recall from one of the earlier screens, we talked about this data and how typical data fall. 95.5% of the data is 2 standard deviations away from the mean. So in my picture here, this 25 appears to be my X bar. And I need to go 1 standard deviation, 2 standard deviations above the mean, and then I need to go 1 standard deviation, 2 standard deviations below the mean, and that will give me the interval of data that has 95% of all the values. So my range would be 21 up to 29. And finally, last question. What's the standard deviation looking at this picture? What's the mean? Well, the mean we can see is definitely 25. It's the middle value, the center of the symmetric value of our normal curve. The bandwidth here, I notice, is 2. And that's what sigma would be equal to. So I guess my answer to this is going to be 2. What percent of the data lie between 23 and 27? Well, that kind of goes back to, this would be a sigma 2, so I have plus or minus 1 sigmas above the mean. And the answer to that is 68.3%. I might have said 65% on that other screen. 68.3% of the data. If there are 500 values of data in this set, how many would be in the interval of 23 to 27? Well, we just said that 68% of the data lies in that region. So let's take our 500, multiply it by 68.3%, and that will tell us the answer to that. 95% of the data lie in this region, 2 standard deviations away. So the interval would be 21 to 29. Tomorrow, let's go back and we'll work with this one in class. But good talking to you. Hope you've got the basics on this.